Welcome. 7th grade, we build a little bit more on what we just did. Okay? Remember, look at this side, combine like terms, then do everything normal. Today, the new thing we're going to add is now there's going to be variables on both sides of the equation. Alright? It doesn't make it much harder. It just adds something you've got to look for. Learn to solve equations that have variables on both sides. So, group the terms with variables on one side of the equation. So we look. Always do this first. Any like terms on this side? No. Any like terms on that side? No. Now, we do want to still combine all the like terms to one thing. But remember, we got to think of this as like moving across. Hey, if I would add 4y to this side and add 4y to this side, those are like terms. They can equal. Oh, 8y plus 4y is 12y equals 60. Oh, now I'm ready to use my division. By 12, divide by 12. Y equals 5. So, just like before, we can move these things around however we want, but when we do them, add 4y, I have to add it to a something y over here. Oh, okay. Okay. All right, so not so bad. Let's show you how they do so it's pretty. They add 4y to both sides. All right, simplify. 60 equals 12y. All right, this one. This and that are like terms. If I add 5b and I add 5b, I would get 72 equals 3b divided by 3, b equals 24. Sorry for the ugly handwriting. It is the same process. Now we just want to look and get all terms that are alike, no matter where they are, together with one, and then we're ready to do our math. All right, so we add the 5b to both sides, simplify, 72 equals 3b, and away we go. Over here, hopefully you can see. Oh, I want to combine these. They're not on the same side, so I have to add 2 to move this. Add 2 then on the other side, because what I do to one side, I have to do to the other side. I will get 8y equals 40, divide by 8, y equals 5. Oh, so we're looking for, and we can combine like terms, even if they're not on the same side, by doing the same thing to each side, like we did before. All right, we add the 2y to both sides. All right, simplify. I get 40 equals 8y. Here, oh, I'm going to add 8b. I'm going to add 8b. 3b equals 24. Then divide by 3, b equals 8. In the first steps here, they're just trying to show you why combining things, even if they're on other sides, by using that whatever we do to one side, we can do to the other side, will get your problem ready to be solved. So, add 8b to both sides. It goes away over here. We combine like terms over there. Now we have a problem that we can solve. That is the whole reason we want to group like terms, even if they're on opposite sides. But remember the process we have to do if they're on opposite sides of the equal mark. Okay? Now, variables on both sides. I see these are like terms. The equal marks is there. So if I subtract 2c, all right, then 5c equals 55. Do you see how I'm now ready to solve the problem? Divide by 5, c equals 11. Okay? All right. All right. There we get it. So, remember, we're not just adding like terms. We have to subtract 2, subtract 2. Do the same thing to both sides so we compare those up. All right. Here. Now, we'll move one thing at a time, especially as you start out. I see that I have m's. I want to probably add 3m, add 3m. Okay, if I do that, these are gone. 7m plus 14 equals 49. I still don't have every like term combined. Oh, I want to subtract 14. I want to subtract 14. 7m equals 35. Divide by 7, divide by 7. And we have our answer. Now, many of you are saying, would the order matter if we added this second and subtracted that first? No, it would still work out the same way. And as long as we're combining like terms, they may even do it all in one step. Let's look at it. So, add 3m on both sides. When we do that, we simplify, we get this problem. Then, we subtract 14 on both sides, and we get 35 equals 7m. Now, the reason we did these two steps is so we could get down to where we have two terms, and then we could do our work. All right, here, all right. Ooh, these are both 1/5 and 2/5, so they have common denominators, so that'll make our life a little easier. If I think this and this are the same, if I subtract 1/5, subtract 1/5, x, don't forget the x, that's important. I would get 1/5 x equals a negative 12. Oh, now I'm ready to undo this. Well, if I want to get rid of that, I can think I multiply by 5 over 1, gone. Multiply by 5 over 1 if you want to think about it. Negative 60 then is my answer. Okay? All right, they subtract 1/5 on each side, simplify, they multiply by 5 on both sides, and you get x equals negative 60. All right, here. They're being nice, they're not doing them where we have both things. Subtract 3f, subtract 3f. The reason we're moving 3f is because we want all the terms without variables on one side and all the terms with variables on the other side. If I were to move 8 over here, I'd have everything on one side and that'd do no good. So we're trying to do this in the fewest moves possible. We'll talk through that on Tuesday. All right, so that would be 5f when I combine those like terms. All right, equals 65. Divide by 5, divide by 5. F equals 13. Combine like terms, even if they're on opposite sides. I'm doing it in the right way by subtracting 3, subtracting 3. Then we do our division, and we get F equals 13. Okay. They subtract 3f from both sides, simplify, they're ready to do their division, and get their answer. All right. So, here we have 2 again. Now remember how last time I said you could have done the numbers without variables first? That works. We'll show you now. I'm going to subtract 9, subtract 9. 54 minus 9 is 45 minus 3q equals 6q. Now, getting these together. Add 3Q, add 3Q, 9Q equals 45. We are now ready to divide by 9. We are ready to divide by 9. Q equals 5. It should work out just the same as theirs. They like to focus on the variable ones first. Okay? We're doing nothing different or extra, or we're doing nothing differently. It's just we have steps prior to what we've been doing. So, they chose to add 3Q first. That's not going to be a problem. It's just going to do our order a little different. They simplify. They get this, 54 equals 9Q plus 9. Then they subtract 9 from both sides. 45 equals 9Q. They come up with the same solution by dividing by 9 on both sides, and 5Q, or 5 equals Q. So the order really did not matter. It's just that we did it appropriately and did the steps correctly. 1/3, 2/3. Oh, they're the same same denominator. Great. So I'm going to subtract 1/3 W. Subtract 1/3 W. 1/3 W equals -9. Don't forget to bring that sign that's with it down. Okay? I know I need to multiply by 3. Goodbye. Multiply by 3. W equals -27 for our answer. Okay? So, we're looking to group the like terms together, even if we have to subtract from both sides or add to both sides. And then we can do our work like we've been doing the last for 12.1 and 12.2. All right, so they're going to subtract 1/3 from both sides. Then we simplify, they say. All right, then we multiply by 3, and we get an answer of -27. Okay, now, Christine can buy a new snowboard for $136.50. She will need to rent boots for $8.50 a day. She can rent a snowboard and boots for $18.25 a day. How many days would Christine need to rent both the snowboard and the boots to pay as much as she would if she buys the snowboard and rents only the boots for the season? So we're setting up an equal sign. So she's trying to figure out, do I buy this for $136.50 and then I add on $8.50 times D for the number of days? When will that equal if I just pay $18.25 a day? Oh, that's the part she'd pay for the snowboard, $8.50 a day for renting boots. Or do I do $18.25 per day to rent a snowboard and boots every day? She's got to decide. So, let D represent the number of days. Boom, we wrote it out. Now, ready to do our math? Subtract 8.5, D. Subtract 8.5, D. All right, so that's 5. 12, that's 7. That's 975. D equals 136.5. I divide by 9.75. I divide by 9.75. And then my number of days is whatever 136.5 divided by 9.75 is. So, we're going to find out how many days it is, and I'll tell you what that number of days tells you. Okay? So, subtract 8.5D from both sides. We did that. They did that. Hey, our numbers worked out. They divide by 9.75. Okay, good. 14 days. If she goes snowboarding for 14 days, renting the material, both snowboard and boots, will be the same price as buying the snowboard and renting just boots. So if she goes more than 14 days, it would be in her favor to buy the snowboard and do that. If she doesn't, well, she may want to just rent both. Okay, so 14 days, she would pay as much, where it would be an equal thing. A local telephone charges $40 per month for services plus 10 cents a minute for long distance calls. Yes, you used to have to pay for long distance calls, not anymore. Another company charges $75 a month for unlimited services. That's more what you're used to. All right. How many minutes does it take for a person who subscribes to the first plan to pay as much as a person who subscribes to the unlimited plan? So, $40 plus 10 cents per minute. Another company just charges flat $75. Well, how many minutes would I have to talk on the phone for this to be worth my purchasing it? So, let M represent that. They wrote it in reverse of me, but it is the same equation. All right, so here, there's only one M. We don't need to do anything with it. Subtract 40. Subtract 40. 35 equals 0.1 M. We divide by 0.1. We divide by 0.1. 35 divided by 0.1 is 350. I would have to talk on the phone for 350 minutes for these to be the same price. All right. If I talk for more than 350 minutes, I'd probably want to do this $75 flat fee. Maybe if I work from home or something like that. Or back in the day, you used to have to be on the internet for a number of minutes. However long you were on the internet was how long your phone call was. It might have been worth it back then. So we subtract 40 from both sides. We get there, we do our division by 0.1. We get 350 minutes. If you're on it for 350 minutes or less, you want $40 plus 10 cents a minute. 350 minutes or more, you're on it for the 75 flat fee. All right. Ladies and gentlemen, have a fun day. Bye-bye.